Good morning, everybody. Welcome back to Math 105. Why did the yardstick want his parents to stop supporting him financially?
He wanted to stand on his own 3 feet.
It's because he wanted to stand on his own 3 feet. Okay, so the plan for today is we are going to start Standard 3, which is about connectives, kind of using words like and or to combine multiple statements into a single compound statement. I expect this standard will likely run into Monday, so I'm expecting Monday will be the day that we actually get through Standard 3. Upcoming office hours, Monday at 10 o'clock and from 2 to 3. And no new homework. I was hoping to have quiz 2 up and running yesterday, but I ran out of time doing other things. My apologies. Quiz 2 will likely be going up then hopefully tomorrow morning. Kind of my plan. Also, speaking of quizzes, several of you have noticed that their Standard 1 retest is posted on Blackboard and have emailed me asking to retest. If you send me an email, I haven't responded about that. I haven't responded to you yet. I need to spend just a little bit more time running through the kinks of like the options I set for these retests to make sure it'll do what I want. But I also plan to send out the password so that you can access it also probably tomorrow. So if you send me an email, I've seen it. It's sitting in my inbox right now waiting to be responded to. I will get back to you tomorrow with that information if you ask me about the retest. If you haven't asked me about retesting yet for this week, you should do that. Can help you out. Any questions or comments before we get started today? Okay, so plan for today is to talk about connectives, which are just words that are used to combine 2 statements into one. So, kind of some common examples in colloquial English are if you have a sentence and another sentence. It's kind of a common way to take 2 sentences, like I went to the beach and I ate ice cream, and combine those into a single sentence, like I went to the beach and ate ice cream, or I went to the beach, comma, and I ate ice cream. Connectives are just going to be these sorts of words that you stick in between two mathematical statements, and suddenly they're a single mathematical statement. So and or, and but, and however, because, would all kind of be examples of connectives that are kind of commonly used in the English language. We are only going to really focus on these first 2, and or. Reason why we don't really care about connectives like but or however or something is because typically the literal meaning of these other connectives are going to be the same as either being and or depending on your situation. Colloquially in English, words like but and however are kind of commonly used to give some connotation to your speech, like to have some like additional meaning, like statement A but statement B. And there's sort of like an unimplied but a little bit of hidden it's sort of implied that you wouldn't expect statement A and statement B to be true at the same time. Turns out they are, so you use the word but. Statement A, but statement B. Mathematics, as we said before, we don't care about connotation at all. We don't care about having like hidden implied meanings. We want all of our statements to be unambiguous and very clearly standing on their own. So typically, you're not going to use words like but and however in mathematical statements. because we will use later on. That'll be more of a standard for sort of word when we get into implication. Standard for is going to be all about how we could, other ways that we can combine statements by saying if statement A, then statement B. So there's a fancy name for each, for and or, that notes I'm working off or using. And is called the conjunction connective. Or is called the disjunction connective. I'm going to be honest with you. I can never remember which is which is why I had to look at my notes just now before I wrote those down. And so I'm pretty much always going to say, instead of being fancy and saying, let's look at the conjunction connective, I'm going to say, let's look at an and statement. Let's look at an or statement. I'm just going to refer to and or by those names because I always forget which is which. So don't worry about trying to remember which is which. Thought I'd show you the fancy names so we could ooh and ah. Ooh and ah for me. Thank you. But ultimately, these are going to be meaningless. But ultimately, those names are just kind of fancy names because mathematicians like fancy names for things. So, start off, we're going to talk about conjunction. Where conjunction means take two statements, combine them into a single statement using the word and. So, if you want to say it out loud, you'll often say, if we have two statements, statement P, statement Q, we can combine them into a single statement by saying P and Q. Or, if you want to be fancy and use the fancy notation, P caret Q is another way that you can kind of write out the notation for statement P and statement Q. So, what does it mean to say statement P and statement Q? In general, we're making a new statement when we say P and Q that's going to be true if both P and Q are true and false if, what does it mean to say that, how can we negate both P and Q are true? Standard 2, we kind of talked about how to negate these sort of quantifiers of both. What would it mean if we said it's false that both P and Q are true, therefore
at least one of P and Q is not true.
Well put, at least one of P and Q is false. So if we were to make a Venn diagram, the only scenario under which P and Q is true is if we're in the overlap where statement P is true and if statement Q is true. If P is true but Q is false, or if Q is true but P is false, or if both of the two statements are false, that would cause the and statement to then become a false statement. In order for the and to be true, it has to be the case that both the individual statements making it up need to evaluate to true in whatever scenario that you're looking at. Any questions before we get into some examples? So let's look at it. Let's look at a few and statements. See if we can kind of evaluate their truth or falseness. China is in Asia, And Brazil is in South America. Is this sentence missing anything? In proper grammatical English? It's missing a comma between Asia and. Technically, we're starting a new clause between China is in Asia and Brazil is in South America. So normally we would put a comma. This is an English class, I would say put your commas there, and if you forget your commas, I'm sorry for you. However, in mathematics, it's more common to not actually use commas. Don't ask me why. If you put in a comma here, it's totally okay, but it's a little more common to not use commas when you're doing these sorts of mathematical statements. So don't worry about the comma if you don't want to. If it makes you feel better to put it in, put it in. If you're worried about forgetting about it, don't worry about it. It's okay to leave it out too, as far as this class is concerned. Now if you go to your English class and say, Dr. Gersel said I don't need commas between independent clauses. Well, that's okay. I don't mind if the English department hates me. I need the science department to like me. So here's a compound statement that uses this conjunction idea, that is made up of an and statement. China is in Asia, and Brazil is in South America. And I'd like to evaluate this compound statement to see if the statement as a whole is whether or not it is true. So what are our two individual statements here? This is made up of two individual statements that are being combined with an and. What's the first of the two individual statements?
China is in Asia.
China is in Asia. So that's our first statement. And the second statement?
Brazil is in South America.
Brazil is in South America. And the and doesn't really isn't part of either of the individual statements. It just sort of serves as a bridge to connect them in order to make this sort of super statement. China is in Asia, true or false?
True.
Brazil is in South America, true or false?
True.
So our first statement is true. Our second statement is true. What does that tell us about the compound statement as a whole?
True.
It's going to be true. Because we are in this scenario where we have a P and Q. If you want, you could refer to China is in Asia as our P. Brazil is in South America as our Q. We said that statement P and statement Q are both true. Therefore, the entire statement as a whole is going to be true. It's both individual statements. On the other hand, flip the page here. Dr. Arn is 500 years old. And Hillsdale students all live in a yellow submarine. I may have been listening to some Beatles yesterday as I wrote this. We again have two individual statements. What do y'all think about this first statement? Dr. Arn is 500 years old.
It appears to be true, but factually it is not true.
Actually, it is true. Okay, it's false. It appears true. Wow, don't tell Dr. Arn that. Hillsdale students all live in a yellow submarine. Probably false. We don't necessarily know that the entire Milky Way galaxy, perhaps, is, say, trapped in a giant yellow submarine. But probably not true. And so turns out we're going to have two false statements here. False statement P, false statement Q, which one of these categories is our compound statement going to fall into?
False.
It's going to be false. At least one of P and Q are false is certainly going to be the case here. In fact, both of them are false. But if either one is false, that's enough to tell us that the whole statement as a whole is also going to be false. Since at least one of the individual statements is false. Pretty straightforward so far. Roses are red, violets are green.
Do we need a qualifier in this since there are different colors of roses? Are we talking about all roses or some roses?
Whenever you don't specify, like if you make a general statement about something like roses or students or professors, generally you kind of assume that there's a hidden quantifier all in there. Unless there's another quantifier that would contradict that. That's a good question. I maybe should. All roses are red and all violets are green.
Well, on the surface we'd say false because generally we think of violets as blue or purple. However, violets do have leaves that are green, so violets are green. That just might not be the way we were intended to think about it.
Ah, so you say, what does it mean to say violets are green? Does it mean to say they are entirely green, or that they have a little bit of green? That's a fair question. I'm actually going to say true. You actually saw through to my hidden meaning here. I was going to try and trick you all by getting you all to say the first one's true and the second one's false, when in fact it's the opposite. Not all roses are red. You typically think of roses are red because nursery rhyme, roses are red, violets are blue. When we say violets are green, you could think like the stem of a violet, for instance, is green. And if it doesn't have a stem, it's not a real violet.
Couldn't you also take the stem of the rose and say that's green too?
Sure, you could. However, I don't think that necessarily affects the statement all roses are red. If we had a statement about all roses are green, then maybe so. And if this is a quiz question, I would let you all get away with like whatever you decided about the truth and falsehood about each individual statement. So here, one of our statements is false, the other individual statement is true. What does that tell us about the compound statement? It's going to be false. By the same reason. And finally, one more and statement before we move on to some or statements. Dr. Gerstle is 32 years old. And Earth has no water on it. You don't think about this one. It's false? Why is that? Okay. What about the statement Dr. Gerstle is 32 years old?
I'm assuming it's true. It's an and statement, so all in that one false.
an interesting point. You don't actually know if the first statement is true. But you said that the second statement is false, and therefore the compound statement is false? I like it. Yeah. This one is a false statement. This one is questionable. But that's actually enough to make the entire compound statement false. If the first statement is false, then both statements are false, and so at least one is false. If the first statement is true, the compound statement would still be false because at least one statement is false either way. Whether Dr. Gerstle is 32 years old is true or not doesn't actually matter for determining whether the combined compound statement is true or false, because we know that the second statement has to be false. By the way, first statement is also false. I turned 32 later this month.
Happy birthday.
Thank you. It's still a few weeks out. I'm end of the month, but. So, in general, with and statements, you need both of them to be true for the compound statement to be true. As long as one or both of the statements is false, that's enough to make your entire and statement false. Any questions about that? That's straightforward. Let's move on to some disjunction. So, or statements are going to be a little bit different. In which we're going to say out loud P or Q, but if we write it down with symbols, it's going to look similar to what we did with and, except for an or statement, we've taken our caret and we flipped it upside down. So now it looks like a little V, so to speak. And now, when we talk about an or statement is going to be true if at least one of the individual statements are true. So at least one of P and Q are true. And if P or Q is true, if at least one of P and Q are true, then what would make an or statement false? How would we negate at least one of P and Q are true?
If they are both false.
Yeah, the only way for an or statement to be false is if both P and Q are false. So if we were to draw a Venn diagram, that we shade in whenever P or Q is true, which parts of the Venn diagram would I need to shade in? For an and statement, it was just the overlap between P and Q. The whole diagram? So everywhere inside of here, including out here?
No,
Yeah. If just P is true, or if just Q is true, or if P and Q are both true, all of those are situations under which P or Q are true. Or statements, I think, are a little bit trickier than and statements to look at. Because when we talk about or in English, what do we really mean? Sorry, I just had to check, make sure I'm still recording. If I were to ask you, would you like salt or pepper with the fries?
It implies that only one can be true.
You can only have salt or you can only have pepper? You can't have both?
Oh, maybe not.
I think colloquial English depends on the context. If I were a waiter at a restaurant and I was asked, would you like salt or pepper with the fries? I think having both would be would be something that would be reasonable to have. By the way, if you really want to be a smart ass, if someone asks you, would you like salt, pepper with the fries? Yes. Both? Both? Just one? You're not going to specify. You're just going to be coy. But if I were to ask you something like, would you like to live in a house or would you like to live in an apartment after you graduate from Hillsdale? Probably meaning one or the other and not both. Probably not. Unless you want to have multiple homes, in which case, lucky you. In colloquial English, when we use the word or, it depends on the situation, whether we mean pick one or potentially both, which is what we mean mathematically. But in English, sometimes when we say or, we really mean just one, you can't have the other. Whenever we use an or statement mathematically, we always include the overlap as well. Meaning, if both P and Q are true, then then P or Q is always going to be true. It doesn't depend on the context in mathematics. If we want to make a statement where only one of P and Q are true, we have to be a bit creative, which we're going to be doing later on this path. Any questions about what the meaning of an or statement is? Okay, what I want you all to do is kind of do the same thing we did with the and statements, but try it with these 5 or statements on the next 2 pages. Is take a minute or two and try going through the or statements on the next 2 pages of the packet and see what you think about if you can determine whether these or statements are true or false as compound statements. Oh shoot, this Dr. Arn Hillsdale students all give the L submarine this time should say or. Sorry, I copied and pasted it and forgot to include the or. I mean, if I did this on a quiz or something by accident, totally go with what is actually written there, but this one was not intended as a trap to have an and statement in the or section. So what do you think about this first one? China is in Asia or Brazil is in South America? Why true?
Because both statements are true, therefore at least one is true.
so it's a true statement.
Yeah, I would agree. This is a true statement. This is a true statement. At least one of the two statements is true. In fact, more than one, but at least one is true. Therefore, the compound statement is going to be true. Dr. Iron is 500 years old, or Hillsdale students all live in a yellow submarine. Yellow submarine. Yellow submarine. Someone say false.
False.
Why is that?
No false.
First individual statement, false. Second individual statement, false. So the whole thing is going to be false, since both the individual statements are false ones. Dr. Percival is at least 3 years old, or Earth has no water.
True.
Why is this one true?
Oh, because you have to be at least 3 years old.
I probably am at least 3 years old.
So at least one of them is true, so the whole statement has to be.
And here is where the compound statement actually change, where if one is true and one is false, here is where or and statements differ. This or statement is going to be true, whereas if I crossed out this or and replaced it with an and, the compound statement would now be false. This one is true for both an or and an and statement. This one's going to be false whether we have a or an and statement. The only time or statements and statements differ is in this case where one of them is true, one of them is false. And so now the or compound statement will be true here, the and equivalent would be false. How about this one? Statement T is true or statement T is false?
It's true, even though we don't know whether each of the individual statements are true. Q negates P, so one of them has to be true.
Ah, interesting. So you're saying, without knowing what statement T is, we can't evaluate each of the individual statements for whether it's true or false, but we can still say something about the compound statement? Whoa.
What if statement T is like a paradox?
Then it's not a statement.
True or false, like that.
Good question, though. See, if paradox T, let's not call it a statement. If sentence T was a paradox, then this compound statement would not actually be a statement because the individual pieces would not themselves be statements. Good question.
Yeah, but I forgot that the definition of a statement is that it's unambiguously true or false.
Yeah. I have to be clear here, when we're defining these compound statements, the individual pieces have to themselves be statements in order for this to be true. This is actually going to be true, I agree, whether or not statement T is actually a true or a false statement. If statement T is true, then we have true, false, or statement will be true. If statement T is a false one, then we would have false, true, compound statement would still be true. If we change this or to an and, could we determine whether the compound statement T is true and statement T is false? Is true or false?
Yes.
How could we do that?
We can confirm because one or the other will definitely be true because they're at odds.
So you're saying, one or the other will definitely be true. We replace or with and. And so what would that do to the compound statement?
Then it would make it a paradox.
It would make it, the compound statement would actually be, I wouldn't say it's a paradox. I would say it's contradictory, and therefore it would have to be false. So if we replace statement T is true and statement T is false, that would be a false statement, no matter whether statement T is true or if statement T is false. Questions about difference between and versus ors. Okay, so let's flip the page now. So here, I give you 5 statements. Jimmy bought ice cream. Jimmy ran to the store. Jimmy played video games. Jimmy played football. And Dr. Dursl's 32 years old. I don't know why I had to include one about me in there in this story of Jimmy. So, I want you to take a couple minutes, work your way through the next couple pages, and I write out a bunch of statements using kind of this symbol notation where the upper caret means and, the bottom, or the V shape corresponds to or. I'd like you to take a couple minutes, see if you can write out what each of these compound statements are saying on this page and on the next page. If you feel like you've written out ways, if you have ways to write out all of these statements, I encourage you to talk to your neighbors and see if they agree with you. If you feel comfortable doing so.
So that's saying that, so he is not very to, or he is not very to, which would be. So you just cancel it out, so. He's not very to, but he is. Yeah, so. Yeah. But this creates a double negative.
It is so switched.
Yeah. He is neither very to or not very to.
You're at the first two.
Parachute expert might
It sounds like you all have had a chance to kind of think about this a little bit. Is this in order? What did you all think about this first one? P caret. I feel like I'm doing a gang sign every time I do this. P caret Q.
Jimmy bought ice cream and ran to the store.
Yeah, the upper caret refers to an and, so I would say Jimmy bought ice cream and ran to the store. Anybody write anything slightly different for this first statement? Because that's not exactly what I had.
Should you write out the whole Jimmy bought ice cream and Jimmy ran to the store?
Yeah, because P refers to a Jimmy statement, Q refers to a Jimmy statement, so do we need both Jimmys? Jimmy bought ice cream and Jimmy ran to the store. Or do you think this is good enough?
Like in the English world, you might not need both Jimmys, but in the mathematical world, you're trying to make sure your both individual statements are accurately represented, so you need to include the Jimmy. And or because you can't just have run to the store and be true or false as a statement. So
This is-
you need the Jimmy in there.
I definitely agree, ran to the store by itself is not a statement. I do think this is fine though, because it is clear, ran to the store in this compound statement, who is the person running to the store, namely Jimmy. And so I think this is fine as a compound statement, even if we don't write out the subject the second time around, because it's still very clear from looking at what the subject of the second statement is. It might take us a little bit more work to break this apart into compound statements. Jimmy bought ice cream, Jimmy ran to the store. But I would say mathematically this is okay to do, as long as it's very clear from the context what it is. But you're right. If statement Q was something like, if P was Jimmy bought ice cream and Q was Carson ran to the store, then we couldn't just have this be the compound statement. We would have to make sure it's clear who is the subject of the second statement. So that. But I definitely agree though, ran to the store by itself is not enough for a statement. Put a Jimmy in here in parentheses, make it clear that that's optional. PVQ. It's not actually a V, but I'm going to refer to it as a V instead of upside down caret because V is a lot simpler to say.
Jimmy bought ice cream or ran to the store.
Jimmy got ice cream or ran to the store. I like it. Same thing. You could also say Jimmy bought ice cream or Jimmy ran to the store. But since the subject's the same in either case, it's okay to just only say it once. How about this one? This time we have a little tilde out in front of our P, which is something we've seen before back in standard 1 and 2. How could we say out this? How could we say this first or this statement colloquially?
Jimmy did not buy ice cream.
Jimmy. Say that again.
Jimmy did not buy ice cream,
Jimmy did not buy ice cream.
and Jimmy ran to the store.
Yeah. So the tilde is a negation, so we're saying P is not true. So Jimmy did not buy ice cream. How about here? Could we say Jimmy did not buy ice cream and ran to the store? Why is that?
Because grammatically we apply the not to both of the clauses. So he did not buy ice cream, he did not run to the store. That's just kind of how I read it, at least.
Yeah, it's a little bit ambiguous this way, whether the not is just referring to the buying of ice cream or if the not is also referring to ran to the store. So I would say in this case, since it's a little bit unclear, here I think it's good to include, I think it's kind of necessary to include the second Jimmy. To make it clear, he did not buy ice cream, but he did go to the store. He did run to the store. How about this one? Not S and not R.
Jimmy did not play football and Jimmy did not play video games.
Jimmy did not play football and did not play video games. I like it. So here we're saying we're negating both of the individual statements, S and R. Jimmy played football becomes Jimmy did not play football. Jimmy played video games becomes Jimmy did not play video games. Here's a big scary one.
Jimmy played football and Jimmy played video games.
Ah, so you're, okay, I see you're trying to kind of simplify as you go along. So you said Jimmy, I'm sorry, can you say what you said again?
Jimmy played football and Jimmy played video games.
Played football and played video games. What do you think about this one? Or does everybody agree with that?
What I did is I said Jimmy did not play football and Jimmy played video games, because if you look at the original statement, as the negation of S and negation of R over there, it's Jimmy did not play football, Jimmy did not play video games. So in order to negate that, we would only really need to change one of the statements, because it's an and statement. So if you just make one of them false, then it technically negates the first one, right?
Well, that would certainly be a situation under which the first one is false. However, I don't think it's...
Isn't that the negation of the first conjunction?
Sort of.
Okay.
I'll say this. You're close. This is a tough one. I purposely gave you all this one because this was actually, in my opinion, the most challenging of the ones on these pages.
If we follow the rules of algebra, because it's outside the parentheses, so you make it negative, and then the negative outside would make the whole then equation negative. So that's why we negate all the negatives, and that's why it turns out to be all of them being he did do this instead of he, because it would just be he did not, so it simplifies it down.
So you have a double negatives canceling out the knots here.
Mm-hmm. So 2 knots canceling out the knots, which is why the outside one, Jimmy played football and played video games. That one, that's why it can simplify down to that.
So I have a proposal for you. Let's say Jimmy played football and Jimmy did not play video games. So let's assume we're in a situation where he played football but did not play video games. Is this statement true or false? If he played football, didn't play video games. That would make this statement false. If he played football, didn't play video games, is this statement true or false? Also false. So is this the negation of that? Very subtle point. Like you kind of got halfway there, but there's another scenario you didn't consider. Here's a thought I'll leave you with, and we'll talk about why on Monday. This is actually an or statement. The negation of Jimmy didn't play football and didn't play video games is actually going to be Jimmy played football or played video games. But we will talk about why that is on Monday. Have a good weekend, everybody. On Monday, we will work our way through the rest of this packet, including talking about how do you negate an and statement versus this or statement. See y'all later.